Sometimes in science and technology, something gets defined a stupid way, and we just can't change it. It would make sense to change it, and we just can't do it. One example is the United States and the metric system, or the old foot-pound system. We can't do the metric system. It's cost us entire space probes, and it doesn't matter. We can't switch. Another example is in current. One thing you must remember is current is the flow of positive charge. And almost all the currents you will think about in the real world are going to be electron flow in a metal wire. So let's look at a metal wire and make this very clear. Here's a metal wire. Okay? We say it has a current in this direction. The current flows this way, from plus to minus. But if I ask you which way are the electrons going, the electrons are going in the opposite direction with some velocity. Okay? Current is the flow of positive charge. Therefore, if you're talking about negative particles moving, they're going in the opposite direction. We call those particles the charge carrier. So if you're ever unsure which way real charges are moving or which way the current is going, if the charge carrier is negative, then it's opposite of the current. So here, the charge carrier is the electron. And you know that the electron is negative. Okay? So the electron should be positive, right? If we wanted to have sort of a nice, simple world where not so many negative signs flying around, back in 17 whatever, we should have made the electron be positive. But it's stuck, it's negative. All this time, we've never changed it. But it really doesn't mean that always that's the case. You can have other kinds of current. Here, you can have a proton beam. That's a current. It can even be measured as a current. In a proton beam, you could say, here's I. Well, what's the velocity? It's going to be the same direction as the current, because the charge carrier is a proton. And a proton is positive. All right? It could even get worse. You can have things going in different directions. In a semiconductor, we keep up with electrons and holes. So I've mentioned holes a couple times, or missing electrons a few times. And in metals, it's not really that important. But in semiconductors, sometimes most of your current can be thought of as holes. So in a semiconductor, if the current goes this way, you can have little electrons flying around, and they'll go this way. And you can have little holes, little lacks of electron flying around, and they'll go that way. So the charge carrier in this case is electrons going one way and holes going the other way. Okay? But that's something to always keep in mind. Current is defined as the flow of positive charge, even if you're working in a metal where all the charge carriers are negative. We can't fix it, we're just stuck that way.